Managing states and events in Jetpack Compose can be challenging, especially if you have multiple different states and events to handle in a single screen. If not managed properly, you could run into issues like UI not updating correctly, events being triggered multiple times, lost UI events after a configuration change, and inefficient recomposition that might affect the overall performance. That's why in this video I'm going to show you how to properly manage UI states and events in Jetpack Compose and the Compose multi-platform. First, we need to start with basics. What is the difference between a state and an event? Well, in Jetpack Compose, we have to deal with two different kinds of data. The first one is a UI state, which represents the current state of our screen. Like, for example, values for different text fields like name, email and password, then the loading state of our data, user profile information, and more. On the other hand, a UI event is some kind of a user interaction or a system change that can be triggered to update the state of our screen. For example, a UI event is a click of a button, typing inside a text field, showing a snack bar message, and other. State should be always preserved to survive a configuration change, which is why it's always recommended to save all your screen states inside the ViewModel. Before we continue, let me introduce you with the sponsor of this video, which is the floppy data. Are you testing your application in multiple regions, managing multiple accounts, or dealing with an API restrictions and limitations? As mobile developers, we often run into these issues when testing our applications. And to deal with those problems, we can use solutions other than VPNs. That's where floppy data comes in, which is a powerful proxy solution designed for a secure browsing, automation, and a large-scale data collection. With floppy data, you get millions of different IP addresses, including city-level targeting. You get flexible proxies, affordable prices, top-tier security, and easy team management. Currently, there is a special offer that allows you to get 100 megabytes of a free proxy to test it out. So, if you are interested and looking for a fast, reliable, and affordable proxy solution, then this is the way to go. Click the link down in the video description to check all great features that floppy data has to offer. Okay, so back to our video. I have prepared one simple project that will allow us to explore different approaches and the potential issues with UI events and states in Jetpack Compose. I recommend watching this whole video, as we will start with a simple example and then work our way through with some improvements. Here we have a simple authentication screen with two text fields and one button. When that button is triggered, we are simulating a sign-in operation over the network. Then, in the ViewModel, we have three different variables or three different states that we are holding here. Besides that, there are also three functions which are used to update those same properties as well. In this case, I'm using a simple compose state and not the state flow. From my personal experience, I haven't had any issues while using a compose state instead of the state flow inside the ViewModel. But I'm going to also talk about a few benefits that you get while using a state flow. Here, we don't need to use remember, because remember is only available within the composable scope. And the ViewModel survives a configuration change by default, which means our state will be retained in such occasions. By the way, I'm using here a private setter for those three states, so that we can modify those values only within the ViewModel. That way, we are preventing potential accidental modifications from the outside of the ViewModel, which is a good practice in general. Now, for the data that comes from the outside of the ViewModel, like for example from a network or a database, I prefer using a state flow. Because with a state flow, it's easier to channel that data from that data source across the ViewModel and to the UI. Because Kotlin Flow has a bunch of different operators that we can use to transform our data before sending it to the UI. And also we can combine multiple different flows and create the new states out of that, which is really convenient. Even though I've said that it's totally fine to use a compose state in the ViewModel, I still prefer using a state flow, because of those all Kotlin Flow operators that are on our disposal. On the bottom of our ViewModel, we also have one function that simulates a network request and updates our UI afterwards. So we have two lambdas that we are exposing to our UI, and if everything goes right, we are calling this onSuccess lambda, which then triggers a snack bar to display a success message. Otherwise, we are calling on error lambda and sending the error message along the way. Alright, so now we're going to launch this application. Let me open up this emulator. There you go. So we have two text fields and a button. If we click this sign in button right away, we will simulate a network request with those 2-second delay, and then we should receive a snack bar message that says invalid credentials. So I have, of course, hard-coded here some values so that we can mimic a success authentication if we type a test for the username and 123 for the password. So in this case, after 2 seconds, we should get a success message, okay? And that's how it works. Now, one thing that we could improve here for now are those states. So at the moment, we have 3 different properties for each state. But what if we introduce here more states than those 3? In a real scenario, you would most likely have more than 3 states in your screen. Which means when you have more states to manage in your view model, it's always a good idea to create the new data class to hold all those states all together. So what would that mean? Well, that would mean that we can create here a new data class, so with the name of authentication screen state. And instead of having those 3 states right here, we will move them in this data class. So let's add here the username of a string type. Then we also can add here the password. And finally is loading a Boolean value. There you go. So with this, now we can modify this example and remove those 3 variables. Instead, I can add here now one private mutable variable called state. I'm going to call here a mutable state flow. So this mutable state flow requires an initial value. So in this case, a default value will be an empty auth screen state. So let's just initialize here this class with its default parameters. In this case, a default value for a username and password will be empty. And for the is loading, we can set here false. There you go. Let's also now create one publicly exposed variable with the name of a state. In this case, we'll use, of course, the state flow as a type, and here authentication screen state. We can now call this underscore state and convert that into a regular state flow. So there are 2 options here. We can use this as a state flow option, or we can use a state in. So the purpose of this state in function will basically allow us to control when those values will be emitted to our UI. So for example, if we don't use this state in function and we just use that as a state flow function, then this state will basically emit all those values even if our application goes into the background. In order to optimize our resource usage, it's always a better approach to use this state in function and specify when you want to stop emitting values from this flow. In this case, the first parameter is the coroutine scope. We are passing the ViewModel scope because we are in the ViewModel. The second one is a started property, and this is the place where we specify when we want to stop emitting those values from this flow. I'm going to call here now sharing started dot while subscribed. We can pass here a timeout, for example, to 5 seconds. So it will mean that this flow will stop emitting its values after 5 seconds of going into the background. This means that this state in function is lifecycle aware, and it can stop emitting values when our application is no longer in an active state. The third parameter here is the initial value, which again we can call just an empty auth screen state with all those default values. Now we can update this authentication screen. We can remove all those values and just observe here the state. Since this is a state flow, we can now call here collect as a state function, add the by keyword to actually unwrap this state flow into the actual state screen. Let's go back for a moment here. For updating those values, we now can use a different kind of functionality. We can call here state.update, and then we can copy the new username. So username equal to value, something like that. Let's just copy this down below, this time only for the password, and for this Boolean is a loading indicator as well. Let's also update here and say state.value.username. Here also, so state.value.password. Okay, let's go back. Here now we can call state.username. So state, there we go, state.password. And down below for the loading as well. So state.loading, and here as well. Perfect. If we launch this application right now, then everything basically will work the same as before. Only in this case, we have improved this whole screen. Instead of having those three properties crowding our view model, now we have moved them inside a separate screen state class. As I already mentioned, this will have much more benefits if you have 10 or 15 different states that you need to hold in your screen class. But of course, with those three, you could also go with that previous example, so that's totally fine. Now, the next thing which we could improve in this view model is how we handle our UI events. So at the moment, you can see that we have exposed those two lambdas from this sign-in function so that we can react in our screen and actually call that scope to launch the coroutine and trigger the snack bar to show those messages. So this approach works well as in the previous example, so we don't have any issues with it. But I think that we could improve how we are handling events from our UI and make our flow more cleaner than before. In which case, I'm going to introduce here a new seal class with the name of a UI event. So in this UI event seal class, I'm going to add a whole bunch of UI events that we have in this screen right now. And so far we have three different events. So we have a enter username event, enter password event, and on a sign-in click. Let's represent now those three events in here. So the first one is a enter username event. We can just call here a data class because enter username event will have also a value of a string type which needs to be used to update our state. So let's here call UI event as well. Add here the val keyword, since this is a data class, of course. The second UI event can be enter a password with a string value as well. And the last one is a simple data object called sign in. This sign in UI event does not need any value or a data that we need to pass here to our view model, which is why we can use a simple data object. Don't forget to call a UI event here as a parent. And now I'm going to create here one more function, which will be called onEvent. It will accept an event type, so UI event. So now here I'm going to say when event is of a type of UI event enter username. Let's also add here other different cases. So we have enter password. And the third one is sign in, right? So when we trigger this enter username event, instead of calling this update username function, we can just now copy or cut this apart and place it right here. So for the value, we need to call now that value or that string data from our class here. So let's call here event.value, like that. Then for the password, we can basically do the same thing. So let's just call this update function and update the password field. And for the sign in, we can trigger this sign in function from here. We can remove now those three functions that we have already made in the previous example. We don't need them right now. Okay. Then when we are updating our is loading state, now we can remove those two and we can call our state flow or a mutable state flow to set here this is a loading state to true in this case, and then false after those 2 seconds, right? Let's remove now those two previous examples. Then we can refactor this sign-in function as well. We can freely remove those two lambdas. We don't need them right now because I'm going to call or actually create the new events that will be sent and observed from the UI. So let's here create the new event. This time I'm going to name this event navigate, and this one show snack bar. Okay, so for the snack bar we can actually add or we can actually create a data class instead, because the snack bar will hold the message of that snack bar. So message of a string type with a val keyword, of course. There we go. So whenever we successfully sign in or when we receive an error, we need to update the event state. However, we also need to observe that event state from the UI, which is why I'm going to create here a new state in our authentication view model with the name of event. So this event state will be represented as a channel. And why channel? Well, because a channel is used for one-time events. Unlike a state flow, a channel can have only one collector or only one subscriber, which is also a perfect case because we only need one observer from the UI of this screen. I have already made a quite detailed video about Kotlin channels, and if you're interested, be sure to check that out. Now that we have created here an event variable, we can observe this variable from the UI and react accordingly. But first, before that, let me just here, okay, so we need to add here an else case as well, because now we have more than those three events. From this sign-in function, we can freely call or actually send a new value to our channel. So event.send. As an element, we need to pass the UI event. In this case, that's the navigate event. In else case, we can also call this send function to send a new event in our channel. And in this case, we can specify a custom message for the show snack bar event type. There we go. So invalid credentials. Awesome. Now in the authentication screen, we can remove those two lambdas, and we can observe now a new state. In this case, that's an event. So event.collect as a state. So when we are collecting our channel as a state, we also need to provide here an initial value. For the initial value, we can specify some kind of an idle event. So let's go back and create here a new event, data object of a name of idle. There we go. So this will be a default event, which will mean that there are no any events. Let's go back and call here UI event.idle. Then we can call here one launched effect block, which will be triggered whenever a new event occurs, or whenever a new event is being sent from our view model. So now the logic of showing those snack bar messages will be moved from this onClick lambda into our launched effect block. I'm going to now copy this snack bar, show snack bar. We can remove all those parameters from here. We don't need this coroutine scope anymore. We already have a coroutine scope in this launched effect block. Again, we can call here when and say when event is UI event.navigate, and also when that event is show snack bar. For the else case, we can just leave an empty block. There we go. So when we successfully sign in, we can navigate to other screen. In this case, we can simply display a message success. In most cases, you would want to implement here some kind of a lambda to navigate to other screen, but for now, just leave it be. In the show snack bar event, we can also call this snack bar state in this show snack bar. For the message, just call event.message. We also need to cast this explicitly to this show snack bar UI event, which is okay. Let's go back down below to fix some of those issues. So whenever we type something in those two text fields, now we want to call that onEvent function. And as an event, let's call here uEvent.enter username. As a parameter, pass that value. And for the password, do the same thing. Instead, just call here a different uEvent. So enter password, right? There you go. And I think that we have fixed most of those issues from this screen. Our view model looks also great for now. Let's check this out and see if this application will function pretty much the same thing as before. So click sign in. As you can see, the loading state has been changed, we have invalid credentials, and when we type here test for the username and the 123 for the password, then we should see here a success message. So it works the same as before, only in this case our authentication of ViewModel looks more structured than before. If you think that we could improve this example furthermore, then you are totally right, because we can also nest those UI events as well. For example, I think that we can nest those two enter username and password events into a new seal class, which could be called input, right? So we just here add those two data classes inside the input event. Then we could create here a new seal class for the, let's say, for the sign operation. We could create here a seal class called button click. Then for the navigate, we can also create here a new seal class to represent that UI action even better. Let's name this a parent class and navigate. And then inside, I'm going to call, for example, the home screen, right? So we are navigating either to home screen or to sign up screen or anything else. And the show snack bar can be a top level UI event here as well. Okay, so now this UI event class looks even more structured than before. Only in this case, of course, we need to add here now that parent, which is the input. And here we have a button click. And we have a navigate.home. Okay, so here as well, navigate.home, here .input.username, and input.password. So now with this, we have improved this overall structure of this ViewModel even more than before. Personally, I think that UI event class seems totally okay. So we have a couple of different nested UI event classes so that we can distinguish user interactions and their actions more clearly than before. Our screen states are encapsulated in this data class so that we don't need to crowd our ViewModel class with a bunch of different states that we need to keep separately one by one. We are using state flow here in our ViewModel so that we can optimize the resource usage if our screen is not in an active state, which means that our application follows the best practices of a life cycle awareness of our components. For the UI events, we are using a channel, a Kotlin channel, which is a recommended approach when it comes to one-time events. This is the perfect use case for using the channels, by the way. And there you go. So I have made sure to showcase all those common things that you are actually writing as a mobile developer. That interaction between ViewModel and your screen is pretty common these days. So basically, each and every feature or each and every screen in your app will have a separate and dedicated ViewModel for it, which means managing your UI state is really important, and keeping your structure clean can also help you scale that project of yours quite easily. So be sure to comment down below, let me know if you have some better approach of handling UI events and managing states in your app with Jetpack Compose. I'm always open to see new suggestions and improvements. Other than that, don't forget to leave a like to this video, but only if you find it helpful. And thank you for watching.
If I die, I'm a legend when they lay me down to rest.